gotta inject some personality into this crew. I was talking about finding order, and you guys are just like, don't make me laugh. I will not smile for you. All right. On the left, we have a fraction. On the right, we don't. So again, the idea, make this look like that. We have tangent, we have secant, we have sine. That's three different trig terms. None of these trig terms are squared. If they were, maybe we'd have a conversation about those Pythagorean identities. None of them are squared, so I'm not going to worry about substitution that way. This is a singular fraction. I'm not going to worry about factoring anything out. We could have talked maybe here. I don't know, go back to this problem very briefly. I don't know if anybody looked at this and said, oh, well, that's the difference of squares. And then I'm going to factor that into conjugates. Now, if that's what you were thinking, does that get you to the end game where we have squared sine over here? So, and it takes a trained eye. It takes a lot of examples to get used to this. But really, it's like, yes, you could factor that down. But that's not making terms that you see over here. Right? You've got sine squareds over here. You've got sine squareds over here. So factoring this down, in this case, just to go back to it for a second, wouldn't have made sense. It made more sense to bring this in so that it was more like what I had over here. Okay? So I have a singular term and I have a singular term. So breaking things up doesn't make sense. Okay, factoring, I'm not going to factor anything here. You know, just give a little preview when we look at this problem. We might want to talk about factoring when we get to this. Because there's this term and there's this term and maybe we can do something. We'll cross that bridge when we get to it. But here, singular term, singular term. Okay, now three different trig values, and when we have more than two different types of trig values and none of them are squared, maybe we want to write them all in terms of sine and cosine. I don't know. I've actually never done this one, so let's see. I'm going to write sine over cosine for tangent. Give myself a little more room here. Sine over cosine is tangent. Secant is 1 over cosine. And is that in fact equal to sine theta? Do I want to write sine theta over 1? In this case, maybe not, because I'm not going to be doing any operations with this. Okay, if you go back to the problem earlier, I had to multiply something by sine, so it made sense to write it as a fraction, because this was a fraction. But in this case, let's see how this shakes out. We have the division of two fractions. So dividing fractions is multiplying by this reciprocal. So I'm going to do this because I have a smart board. Really, this becomes times cosine theta over 1. And when we multiply two fractions, you can multiply across and create that one big fraction, or you can recognize that these are common terms and we can cross cancel when we multiply fractions. So we get sine theta over 1 is equal to sine theta. Yes, it is. I don't need to have this as over 1. I don't need to write this. We recognize that, yes, obviously these are the same. All right? Pretty straightforward on that.